The next topic is section formula. So in 10th standard also you studied section formula, that is, if R divides a line segment joining two points PQ in XY plane, then coordinates of R. Okay, if the ratio is given, then we can find coordinates of R. The same way here the points in space. So the given points are P and Q. P x1 y1 z1 and Q x2 y2 z2. Let R divides PQ, the line joining or line segment joining PQ in the ratio m is to n. In the ratio m is to n. So what are the coordinates of this R? So I took R generally as x comma y comma z. So we have to find x, y, z in terms of x1 y1 z1 and x2 y2 z2 and m and n. So the proof is, or how to find the formula for that. So P and Q given, R is a point which divides PQ in the ratio m is to n. Then from P draw a line parallel to z axis to this xy plane, and from R also and from Q. Okay. Now from here, then from R to this QM, one straight line RT, to this PL, the straight line that is S. So here we get a triangle. Okay, two right angled triangle. Now consider the triangle PSR. Triangle PSR and triangle QRT. This angle S is 90, angle, not that one, angle T is 90. Okay. Now angle SRP and angle QRT, they are vertically opposite angles. So they are equal, and angle S and angle T, that also equal. That is, two angles of triangle PSR and triangle QTR are equal. That means triangles are similar. Triangle PSR and triangle QRT are similar. If two triangles are similar, then their corresponding parts are proportional. So corresponding parts, we can write PS by QR equal to SR by RT is equal to PR by QT. So here we write PR by QT. That is, PR means M. And RQ, QR means, here you have to write, how to write, QTR. So PR by QR. PR is M and QR is N. Now we take this side, PS and QT, PS and QT, which is equal to the third side SR and TR, that I am not taking now. Okay. So the corresponding parts are proportional. Now what is PR? PR is M by N is equal to. Now what is PS? PS is same as SL minus PL, isn't it? SL minus PL. Now what is QT? QT is QM minus TM. QM minus TM. Then what is this SL? Can you say what is SL? These are parallel to Z axis. So we can express in terms of Z coordinates only. So SL. SL is same as RN. SL is same as RN minus PL. Then QM and TM. TM is same as RN. Then what is RN, children? RN. It is parallel to Z axis. So it is same as the Z coordinate of this point R. So Z coordinate of R is just Z. Now what is PL? PL. It is equal to z coordinate of P, that is z1. Now QM, what is QM? That is z coordinate of Q, that is z2, then Rn is z. Now we have to cross multiply. So m into z2 minus z is equal to n into z minus z1, or which implies mz2 minus mz is equal to nz minus nz1. Okay, or what is z? Z means z coordinate of R, that only we have to find. So mz2, take nz1 to the left side, mz to the right side, so m plus n of z. Okay, so z coordinate is equal to mz2 plus nz1 by m plus n. This is the z coordinate of R. Similarly, when we take the other side, you will get. Similarly, the x coordinate we can write as mx2 plus nx1 by m plus n. And y coordinate is my2 plus ny1 by m plus n. Okay, so what is the section formula? If R divides PQ in the ratio, if R divides PQ, what is P? X1, Y1, Z1, and Q, X2, Y2, Z2 in the ratio m is to n. In the ratio m is to n, then the coordinates of R. Three coordinates are there. The first coordinate is mx2 plus nx1 by m plus n, and my2 plus ny1 by m plus n, and the third coordinate is mz2 plus nz1 by m plus n. Now this is internal division. What do you mean by internal division? This R is in between P and Q. Okay. Sometimes the division is not internal, externally. Externally means PQ is the line segment joining P and Q. Sometimes this R is outside. That is, R divides PQ in the ratio m is to n externally. That is, R is outside the line PQ. Okay. So PR is m, QR is n. That is known as external division. So the formula is same, but you have to replace n by minus n. So here this formula we apply if R divides PQ internally in the ratio m is to n. Okay, internally, you have to add the term internally. Then the next case is if R divides PQ externally in the ratio m is to n, then the coordinates of R, the formula is mx2 minus nx1, wherever n you have to change as minus n, by m minus n, then my2 minus ny1 by m minus n, then mz2 minus nz1 by m minus n. This is the external division. Now, if R is the midpoint, if R is the midpoint of PQ, then m is to n becomes 1 is to 1, isn't it? R is the midpoint of PQ. Then what about the coordinates of R? X1, internal division, okay? Midpoint means it is in between P and Q. So here mx2 plus nx1 becomes x1 plus x2 or x2 plus x1 by 2. M and n 1 and 1. Then the next is y1 plus y2 by 2 and z1 plus z2 by 2 if R is a midpoint of PQ. Then in some questions, the question will be what is the ratio? Find the ratio in which R divides PQ. Externally or internally. So if the question is find the ratio, you can use the same formula m is to n, or the easy way is we can use k is to 1. The ratio as k is to 1. That is R divides PQ in the ratio k is to 1. It's an easy method, that's only. So if R divides PQ in the ratio k is to 1, then coordinates of R is, instead of mx2 we can write kx2 plus nx1, that is x1 by k plus 1. Okay. Then ky2 plus y1 by k plus 1. So if the question is find the ratio, we don't know whether R divides PQ externally or internally. After getting the answer only we can conclude. If the answer k value is positive, then the division is internal division, or if k is negative, it is external division. Okay. So you can use the same formula for internal or external, because we don't know whether it divides internally or externally. After getting answer only we can conclude. Okay. So if the question is find the ratio, we can use this. And we can do problems. Find the coordinates of the point which divides the line segment joining the points 1, minus 2, 3 and 3, 4, minus 5 in the ratio 2 is to 3 internally and externally. So here we have given 2 points P and Q. Let R divides PQ in the ratio 2 is to 3. 1, minus 2, 3. 3, 4, minus 5. Okay. So what about R? The coordinates of R, the first case is internally. That is mx2. 2 into 3 plus 3 into 1 by 2 plus 3, comma 2 into 4 plus 3 into minus 2 by 2 plus 3, comma 2 into minus 5 plus 3 into 3 by 2 plus 3. So 3 2s are 6, 6 plus 3 is 9, 9 by 5, 8 minus 6 is 2, 2 by 5, minus 10 plus 9 by 5 is minus 1 by 5. Now the second case is externally. Externally, if R divides PQ in the ratio 2 is to 3 externally, then the formula is 2 into 3, then put minus sign, 3 into 1 by 2 minus 3. Then 2 into 4 minus 3 into minus 2 by 2 minus 3. Then 2 into minus 5 minus 3 into 3 by 2 minus 3. So 2 3s are 6, 6 minus 3 is 3, 3 by minus 1 is minus 3, 8 plus 6, 14, 14 by minus 1 is minus 14, and minus 10 minus 9, that is minus 19. Minus 19 by minus 1 is 9. Given that P, Q and R are collinear, find the ratio in which Q divides PR. They are collinear means they are on the same line, P, Q and R. P, Q and R. Okay. We don't know whether Q is in between P and R or external, that is internal division or external division, that we don't know. Here the question is find the ratio. So we take as K is to 1. Okay. Let Q divides PR in the ratio k is to 1. Therefore, Q, coordinates of Q, what is P? P is 3, 2, minus 4. Now R is 9, 8, minus 10. Okay. So, the coordinates of Q is also given. So, using this, that is Q divides PR in the ratio k is to 1, we get coordinates of Q in terms of k. Then you have to equate that coordinate with the given coordinates. So, coordinates of Q is 9 into k, 9k plus 3 by k plus 1, then 8k plus 2 by k plus 1, and minus 10k minus 4 by k plus 1. Okay. Now we equate this Q to the given point. Okay. 9k plus 3 by k plus 1 is equal to, here x coordinate I am taking. So, x coordinate is equal to x coordinate, which implies 9k plus 3 is equal to 5 into k plus 1, or which implies 9k plus 3 is equal to 5k plus 5. Take to the left side, 9k minus 5k is 5 minus 3, which implies 4k is 2. So, what is k? 2 by 4, that is 1 by 2. So, what is k is to 1? The question is find the ratio. K is to 1 is equal to 1 by 2 is to 1, that we write as 1 is to 2. So, here k value is positive. So, from that we can say that Q divides PR internally in the ratio 1 is to 2. Therefore, Q divides PR internally in the ratio 1 is to 2. Find the ratio in which the YZ plane divides the line segment formed by joining the points 4, 8, 10 and 6, 10, minus 8. So, here also 2 points are given. Let the point be P and Q. 4, 8, 10 and 6, 10, minus 8. It's a line segment. It is divided by the plane. Plane is like this. Which plane divides YZ plane? The plane is YZ plane. In YZ plane, x coordinate is 0. In YZ plane, x coordinate is equal to 0. Okay. So, we take as, here also we have to find the ratio. So, we take let YZ plane divides the line segment joining the line segment. YZ plane divides the line segment joining the given points in the ratio k is to 1. K is to 1. Therefore, how to write the coordinates? So, k into 6, isn't it? That is 6k plus 4 by k plus 1. And the next one is 10k plus 8 by k plus 1 and minus 8k plus 10 by k plus 1. Okay. So, this YZ plane divides the line segment joining the given points in the ratio k is to 1 means in the YZ plane there will be a point. That point divides this PQ in the ratio. That is the meaning. So you can give, let this be equal to some R. Okay, R is a point in YZ plane. Now in YZ plane the x coordinate is 0. So we can equate x coordinate to 0. Since x coordinate equal to 0, we can write 6k plus 4 by k plus 1 is equal to 0. So from that 6k plus 4 is equal to 0. So 6k is equal to minus 4, or k is equal to minus 4 by 6. That is k is equal to minus 2 by 3. So this minus sign indicates the division is externally. Okay. So we can conclude, therefore YZ plane divides the given points externally in the ratio Here k is minus 2 by 3. What is k is to 1? This minus you can neglect now. Minus indicates external division. So it is 2 by 3 is to 1, or we can write as 2 is to 3. Okay. So YZ plane divides the given points externally in the ratio 2 is to 3. Here I wrote externally, then no need of this minus sign here. Okay. Next one. Using section formula, show that the points A, B, C are collinear. So in the last video, show that the points are collinear using distance formula. Here we have to prove the points are collinear using section formula. Section formula, that is, we have to prove all the 3 points on the same line. So we take, first you have to take any 2 points, either AB or BC or AC. Then we take another point P. P divides this AC in the ratio k is to 1. Let P divides AC or AB or BC, whatever you want you can take. P divides AC in the ratio k is to 1. Therefore, coordinates of P, A and C you have to take. So k into 0 plus 1 into 2 by k plus 1. Then k into 1 by 3 plus 1 into minus 3 by k plus 1. Then k into 2 plus 1 into 4 by k plus 1. These are the coordinates of P. That is 2 by k plus 1, k by 3 minus 3 by k plus 1, then 2k plus 4 by k plus 1. Now what we do is, we have to prove this P and B. First I took A and C. So the point left is B. So I have to prove this P and B are same, they coincides. Then we can say that all these on the same line. So for proving P and B coincides, first we take the first coordinate and equate to the first coordinate of B. So to prove B and P coincide, you have to take 2 by k plus 1 is equal to minus 1. X coordinate equal to x coordinate, or you can equate second coordinates or third coordinates. So which implies 2 is equal to minus k minus 1, or k is equal to minus 3. Okay. Now we have to verify. That means substitute this k in the second and third coordinate. So when k is equal to minus 3, what about the second coordinate? K by 3 minus 3 by k plus 1 becomes minus 3 by 3 by minus 3 plus 1. Minus 3 by 3, it is minus 1. So minus 4 by minus 2. What is it? 2. 2 is the second coordinate of B. Yes. Now you have to substitute k minus 3 in the third coordinate. So when k is equal to minus 3, 2k plus 4 by k plus 1 is equal to 2 into minus 3 plus 4 by minus 3 plus 1. That is minus 2 by minus 2, that is equal to 1. Is 1 is the third coordinate? Yes. Okay. So first you have to equate any one coordinate. From that you will get the value of k. Substitute k value in the other two coordinates and you have to compare with the other point B. Okay. So we can conclude that therefore P and the point B coincides. They are same. P is not any other point, it is same as B. Okay. So first what we took, P divides AB. P divides AC in the ratio k is to 1. So here, from here we understood that P and B are same. So B is also on the same line. Therefore A, B and C are collinear. This is a method to prove collinearity using section formula. So 3 points will be given. You have to take any 2 points and take P. P divides that 2 points in the ratio k is to 1. Then equate any coordinate of P to the coordinate of B, corresponding coordinates of B. From that you will get k value. Then compare the other 2 coordinates also. Here this is one method. The other method is, here after getting k, I substitute this k value in the second and third coordinate. The other method is, after getting k is equal to minus 3. That is equating first coordinate. From that you get minus 3. Now equating second coordinates. Second coordinate, which is the second coordinate? K by 3. K by 3 minus 3 by k plus 1 equal to 2. So k minus 9 by 3 into k plus 1 is equal to 2. That is k minus 9 is equal to 2 into 3, 6, 6k plus 6. Or minus 15 is equal to 5k. So k is equal to minus 3. Again the same value. Now equate the third coordinate. What is the third coordinate? 2k plus 4 by k plus 1 equal to the third coordinate 1. So 2k plus 4 is equal to k plus 1 or k is equal to minus 3. So all k values are same. Then also you can conclude that P and B are same. P and B coincides. So the points are collinear. One, find the coordinates of the points which trisect the line segment joining the points. Trisect means 3 equal parts. That's the meaning of trisection. 4, 2 minus 6, Q, 10 minus 16, 6. We have to find the coordinates of the points which trisect 3 equal parts. So there must be 2 points. Then only we get 3 equal parts. So let R and S. Okay. Let R and S divides trisect. Bisect means 2 equal parts. Trisect the line segment PQ. Then we have to find the coordinates of R and S. So trisect means equal parts. Ratios are equal. That's the meaning. So 1 here, 1, 1. Ratios equal. If it is 2:2:2, then we can reduce it and we can write 1:1:1. Okay. So all the parts are 1. Now for finding R, we can use section formula. From this figure, we can write R divides PQ in the ratio. What is the ratio? PQ in the ratio. The left side of R is 1. Right side is 1 and 1. That is 1:2. R divides PQ in the ratio 1:2. So what about the coordinates of R? Therefore R 1 into 10 plus 2 into 4 by 1 plus 2. Then 1 into minus 16 plus 2 into 2 by 1 plus 2. Then 1 into 6 plus 2 into minus 6 by 1 plus 2. So what about the coordinates? 10 plus 8, 18 by 3, 6. Minus 16 plus 4, minus 12. Minus 12 by 3, minus 4. 6 minus 12 is minus 6 by 3, minus 2. Now we have to find S. So S divides PQ in the ratio. The left side of S is 1 and 1. That is S divides PQ in the ratio 2:1. You can use that method, or the second method is S is the midpoint of what? S is the midpoint of RQ. Okay. S is the midpoint of or you can use section formula. S divides PQ in the ratio 2:1. That method also possible. Okay. Here S is the midpoint of RQ. So what about S, coordinates of S? Midpoint formula. R and Q you have to take. What is R? 6. So x1 plus x2, that is 10 by 2. Next coordinate minus 4 plus minus 16 by 2. Minus 2 plus 6 by 2. That is 16 by 2 is 8. Minus 20 by 2 is minus 10. 4 by 2, that is 2. So that is the coordinate of S.